Welcome back. Today we're going to finish up looking at how to graph these rational functions when they're not in our basic transformation format. When we have things like y equals a over x minus h plus k, we can see the stretch, we can see the left-right shifts, the up and down shifts, so we graph those differently. We're looking at specific rational functions where we have some polynomial divided by another polynomial. Okay, we started talking about these yesterday, and we did the first part of these steps. So yesterday we looked at factoring the numerator and denominator if we needed to, and then if a factor in the denominator cancels, we said it left a hole. If the factor in the denominator doesn't cancel, it leaves a vertical asymptote. We're going to abbreviate that VA. Then we looked at analyzing the degree. So we wanted to figure out the horizontal asymptote. Again, we're going to abbreviate that HA. And we said if the degree on top is smaller than the degree on the bottom, then the horizontal asymptote is at y equals 0. If the top degree is more than the bottom degree, then there isn't a horizontal asymptote. And if we have the same degree for both the numerator and denominator, then we look at the ratio of our leading coefficients. So this is where we kind of stopped yesterday. And now today we're going to start filling in some more of those details and actually graph these. So we're going to find both the x and y intercepts. We find the y-intercept by plugging a 0 in for x. Okay? Then we find the x-intercept by setting the numerator equal to 0. We're actually plugging a 0 in for y, and I'll show you as we go through an example why that really equates to just setting the numerator equal to 0. We're then going to plot all of these pieces on our graph. Any holes, any vertical asymptotes, any horizontal asymptotes, any x or y intercepts. Once we do that, then we're going to grab our graphing calculator to actually help us sketch the branches of our graph. All right, so here's a couple examples of some graphs that you might see. The first one looks a lot like our basic left, right, up, down kind of shifting transformations. The second one shows us two vertical asymptotes and a horizontal asymptote. We have vertical ones here and here. We have a horizontal one right here. So we do have both kinds of asymptotes, and our graph is approaching those asymptotes. This is a typical shape you might see. The last one, the last picture, same thing. We have two vertical asymptotes and a horizontal asymptote. It looks like it's at the x-axis, y equals 0, but a slightly different shaped graph. So we're not expecting you to be able to predict exactly what those graphs look like. We are asking that you plot all of the key information that we've described in steps 1 through 4, and then you can use your calculator to help you get the branches correct. All right, so from yesterday, we started this question. We had y equals x minus 4 times x plus 6 divided by x minus 3 times x minus 4. So we had already factored it, and we had looked at the fact that this first x minus 4 piece drops out. So that was a removable point of discontinuity, which led to a hole. So yesterday we figured out that our hole was at the point 410. We then looked at the point of discontinuity that doesn't drop out, where x equals 3, and that led us to a vertical asymptote. And then we also studied the degrees. We said the top degree was 1, the bottom degree was 1, so we looked to the leading coefficients since our degrees were the same, and our leading coefficients were also 1s, so we had a horizontal asymptote at y equals 1. Okay, so we could graph all of that information. We can put our horizontal asymptote at y equals 1. Asymptotes are always drawn in with dotted lines. We can put our vertical asymptote in at x equals 3. And we know that there's a hole at the point 410. So at the point 410, we're just going to do an open circle. We know there's going to be a hole there. What we still need to fill in is any x and y intercepts. So if we go to our simplified equation, y equals x plus 6 divided by x minus 3. To find the y-intercept, we simply put a 0 in for x. Well, if we put a 0 in for x here, we've got y equals 0 plus 6, which is 6, divided by 0 minus 3, which is negative 3, and we end up with a negative 2. So we know that we're going to hit our graph at 0, negative 2. Okay? To find the x-intercept, we need to plug a 0 in for y. And so if we put a 0 in here, what we end up with is 0 equals x plus 6 divided by x minus 3. And if you think about solving that, picture there being a 1 under here and thinking of it as a proportion. When we cross multiply, we have 0 times x minus 3 equals 1 times x plus 6. But 0 times anything is just 0. And 1 times anything doesn't change it. We're still left with x plus 6. So the net result is that we are really, when we plug a 0 in for y, we're really looking at what makes the numerator equal to 0. Okay? So solving that, we end up with x equaling a negative 6. So we've got the point negative 6, 0 would be our x-asymptote, or sorry, our x-intercept. All right, so based on the information that we have right now on our graph, looking at the asymptotes, looking at our x and y intercepts, knowing where that hole is, I could predict, we had a vertical asymptote here, we had a horizontal one here, I could predict this shaped graph. We know it's going to approach that hole, and it has to approach our asymptotes, and we know it has to hit these intercepts and approach the asymptotes. So we can expect to see that kind of a picture, kind of a graph, where we have two separate branches. But to actually get the graph and to check it, we do want to go to our calculator. So grab your graphing calculators. The key to typing this in our calculator is to use parentheses around your whole numerator and around your whole denominator. So we're going to go to our y equals screen. And our equation was y equals the quantity x plus 6. So I'm going to put this in parentheses, x plus 6, divided by, and again, parentheses around the whole bottom, x minus 3. And then I'm just going to do a zoom 6 to reset my window to a nice negative 10 to 10 window. And we're seeing that same kind of shape that I was describing. Okay? We can always go to our table and look at some points. Notice that you see an error here. When x is 3, that is our vertical asymptote that we're looking at. All right. We also see this point here, 410. Now, it's in our table, but it is a hole, because if we looked at the original equation, we graphed the simplified version, but based on the original equation, there was a hole there. All right, so our final picture, we should have a branch on the upper right side here, upper right quadrant. Again, it's approaching the asymptote. It's going to pretend it's kind of skipping over that hole. And then we also have one in the lower left here. Okay? So we're going to try the next one, going through the whole process. So step 1, we want to factor everything. Well, the numerator would factor into x plus 4 and x minus 3. Denominator factors into x plus 2 and x minus 2. Okay? So everything's factored. Then we look at points of discontinuity. So any problems, what would make the denominator 0? So here, when x equals negative 2, that's a problem. And when x equals positive 2, that's a problem. But when I look at the numerator, neither of those cancel out. So we're going to have actually two vertical asymptotes, one at x equals -2 and one at x equals +2. So let's go ahead and fill those in. All right, now we didn't have any points of discontinuity that actually dropped out, so we can just say there's no holes for our graph. The second, or step 3 here, looks at finding the horizontal asymptote. Again, we're analyzing the degree, and if we look at our degrees, the top degree is 2 and the denominator degree is also 2. So we have same over same situation here, which means we look to the leading coefficients. And my leading coefficients, again, are just 1s. So I have the equation y equals 1 divided by 1, which is just 1. All right, so horizontal asymptote at y equals 1. Then we need to find some other points to plot. Again, we're looking for those intercepts. Those are the easiest ones to figure out. So let's put a 0 in for x. Now you can plug it into either the original equation or the factored version. It doesn't matter. Most of the time I like plugging it into the factored version. But you can do either one. All right, so if we put a 0 in here for all of our x's, we end up with, for the numerator, 4 times -3, which is -12. For the denominator, we end up with 2 times -2, which is -4, and that simplifies to be a 3. So we know that the point 0, 3 we plugged a 0 in for x, we're getting 3 for y, that is my y-intercept. To find the x-intercept, we put a 0 in for y, but again, if we plug a 0 in for y, and we cross multiply, the bottom part actually drops out because it's getting multiplied by a 0. So we're really looking for what makes the top 0. And we actually have 2, because looking at it in factored form, what makes this a 0 would be -4, and what makes this one 0 would be a +3. So we have 2 points that are x-intercepts. We have -4, 0, and we have 3, 0. So let's go ahead and plot those. -4, 0, and 3, 0. All right. So we've plotted all the information that we've found. Now we're going to plug it into our calculator. My recommendation would be to put in the unfactored version, because the factored version has so many parentheses that it can get a little bit confusing where we need them all. All right. So let's clear this one out, and let's put in parentheses. My numerator was x squared plus x minus 12. Close that parenthesis off, divided by parenthesis x squared minus 4. And close off that parenthesis. And then we're going to graph it again, and we can see the shape that we need to sketch. All right, so in between our vertical asymptotes, we have almost a parabola looking shape. And then on the outside of our vertical asymptotes, again, we'd have vertical asymptotes here and here. We had a horizontal one at 1. All right, so we're going to transfer that shape onto our picture. So we had a kind of a U-shaped graph in here, and we had branches that came up along that vertical asymptote, crossed at the x-intercept, and same thing over here. All right, let's try another one. Our first step, again, is always to get everything factored. So the numerator is fine, x plus 3. Denominator would factor into